we are going to start with work and first law of thermodynamics. They may ask you, write down a short note between work and first law of thermodynamics. See, what does mean by work done? Work done we understand very easily. Suppose if I have an object over here, let's say we have an object over here. Okay. In this object, suppose if I apply a pressure, इसके ऊपर हम pressure लगा रहे हैं. If I apply a force, but by applying force, if this object remains at the same place, there is again it does not change its position. By applying force F, there is no change in its position, then no work is done. Then when there is a work done. So this is not a work done. See, I am applying pressure force on this wall. That is what is not doing this. We don't say work is done. But yes, work is done. Work is done. When you apply force and there is a movement, there is a displacement. Yes or no? So when you are applying this force over here, when you are applying this force and there is a displacement, and if there is a displacement, then the work is done. By applying force, if displacement takes place, then work is done. Yes or no? What is work? But you know. Now in chemistry, we see normally two kinds of work. In chemistry, we see two kinds of work. First work is electrical work, and second work is mechanical work. Normally, when we talk about electrical work is associated with this kind of thing. Okay, like I explained, suppose in a container, if I have some water in it, and if we place two electrodes, and if we supply some electricity to this, if we supply some, let me take some space over here. Supply some electricity by connecting our battery. Then we know here hydrogen and oxygen bubbles are involved. So what is electrical work? Electrical work is normally associated with when you supply electrical energy, and due to that there is some chemical reaction is taking place. That electrical work is being done on system. It may be other way also. Some chemical reaction is taking place, and due to that, electrical energy is produced. We know in powers, battery cells, the power cell, chemical reaction takes place and produces certain energy. That electrical work is involved. Okay. And normally during that process, ions are responsible for conduction of electricity. However, about this point, electrical energy, we are going to study in sem 3. We are going to study about this topic in semester 3, not right. Second point which we need to learn, that is mechanical work. What we need to learn is mechanical work. Suppose if I have a system over here, let's say I have a system which contains, let's say, certain quantity of gas. इसके अंदर क्या है? There is some quantity of gas which has initial volume V1, and if we supply some pressure, suppose this is a system and here we are applying some pressure. We are applying pressure in this case. Because of that, what happens? See, something happens. Here, I am applying pressure on this. When we apply pressure, this thing goes down, and since that thing goes down, because of that, the volume decreases. Because of that, volume decreases. You can see the difference between the volume over here. Initial volume was this much, which we call V1. Now the volume has changed when we do work on system. Volume has changed to V2, which is less than that, which is less than earlier. You can see that the volume has decreased, isn't it so? When we do mechanical work on system, here we are doing work on system. Okay. Work on system. Work done on system rather. Work done on system. Work is done on system. Then we call it positive work. Then what do we call it? And due to that, आपको नया volume V2 मिल रहा है. But you understand, during that, V2 is less than V1. When we do mechanical work, is less than V1. That's the one case the mechanical work is done on the system. Another case, suppose the work is done by system. Suppose work is done by system. Then what will happen to this? At that time, when the work is done by system, when the work is done by system, when the work is done by system, we will see this point. Work is done by system, that means this system is doing the work. Because of that, this will go up and volume increases and it pushes this piston up. Pushes the piston up. Are you following this? Initially, you had this much volume V1. Now the volume has changed to V2. And when the work is done by system, we call this negative work. At that time, V2 is greater than V1. Mechanical work is called pressure volume work. When there is a change in pressure, the volume changes. That is called mechanical work. Are you following me? In thermodynamics, we have to study about mechanical work. which is called pressure volume. Okay, in one case, pressure is being done on the system, that is given to the system, work is done on the system, volume decreases. And if the work is done by system, volume increases. Is it fine? So by the way, we continue, before we continue further, let me mention one important point. Pressure volume 1 is applicable to only gaseous system. Pressure volume work is not applicable to solid or liquid system. मतलब जहाँ पे सॉलिड एंड लिक्विड यूज होते हैं वहाँ पे प्रेशर वॉल्यूम वर्क काम में नहीं आता है. क्यों? बिकॉज सॉलिड्स आर incompressible. We had seen, we had pressed this wall, nothing happens to that wall. Okay, they are incompressible. Even liquid is incompressible. यहाँ तक कि if you have 1 liter of water and normally it is kept at 1 atmospheric pressure, if we increase pressure by 1000 atmosphere, if we increase pressure by how many atmosphere? 1000. The change in volume of that liquid is only 4%. By increasing 1000 temperature, the volume changes by 4%. So, okay, when we are going to use pressure volume work, we are going to use it only for gaseous system, not for solid or liquid system. Is that understood? Are you following me? One important point I had explained you over here. First thing, it is used for the gaseous system, pressure volume work, mechanical work. Second point, when the work is done on system, volume decreases, work is positive, and work is done by system, volume increases and work is negative. Achha, we continue further. See over here. Okay. Now here, what do I have? As I said, work done on system, we call it positive work, and at that time V2 is less than V1. Correct or not? Second point which I have mentioned to you, work done by system, we call it negative work. At that time, I'm sorry, I taken wrong. At that time, negative work and V2 is greater than. Correct or not? Now, normally जब mechanical work की बात करते हैं, work is derived by this formula. W equals to P delta V. W equals to P delta V. And the unit of this work is bar liter. Liter bar. Because pressure is measured in bar and change in volume is measured in liter. And if I write P equals to V2 minus V1. Now there are ध्यान से देखेंगे. If we see the first case, where the work is positive and V2 is less than V1. If we put it over here, V2 is less than V1, then what will the answer? Okay, what is the sign of this? I think so it's negative. When V2 is less than V1, आपका W कैसा आ रहा है? Negative. If we put it in this formula, it becomes negative. It was supposed to be positive. Okay. And if we take the second case, when V2 is greater than V1, that means when the work is done by system, work was supposed to be negative. Work was supposed to be negative. But if you put it over here, it becomes positive. Am I right? That means, according to the mathematical form of the first law, work was supposed to be positive, but our formula gives it negative. And according to the first law of thermodynamics, work was supposed to be negative and formula gives it positive. To avoid this confusion, normally we are going to take W equals to minus P delta, not this. What we are going to take? W equals to minus P delta, because then it settles the product. When positive becomes positive, negative becomes negative. Are you following me? Suppose they ask you, derive relationship delta U equals to QV and 2. So 2-mark question. Then what are we going to do? We are going to write down like this. Okay, you don't write till I finish the topic. You pay attention only. For our process, taking place at constant pressure, suppose taking place at constant pressure P, if initial volume of system is V1 and final volume of system is V2, then work exchange W equals to minus P delta V or minus P V2 minus V2. Keep it point of 1. Correct or not? Very simple thing I have written over here. Very simple thing I have written over here. Okay. For a process taking place at the constant pressure P, if the initial volume is system is V1 and final volume is V2, then the work exchange is this. Okay. Now, first law of thermodynamics. First law of thermodynamics says delta U equals to Q plus W. Okay, where Q is heat exchange and W is work exchange and delta U is change in internal energy. We know about this, correct? Putting W equals to minus P delta, then delta U equals to Q minus P delta. Are you getting this? Very simple words, very simple thing I am writing over here. Very simple. Okay. Now, suppose during process delta V equals to 0 or final volume and initial volume are same, then delta V equals to 0. Suppose there is no volume changing. Okay, we started with that. Suppose there is a change in volume, but there is no volume is changing. At that time, heat exchange Q, we write QV. What do we write? Heat equals to Q equals to QV. Why? Because we take heat exchange at constant volume. Let us put it over here in this equation. So therefore, delta U equals to QV, and since delta V is 0, so this part becomes 0. Just to finish, after we have derived our equation, that's what they asked. They asked delta U equal to QV derived. It already derived. Correct or not?